Chapter 11. Sanitation Preventive Controls for Human Food. Sanitation is the beginning, not the end, of food processing. It establishes the basic hygienic conditions needed to produce safe and wholesome food. Without a clean operation to start, equipment and the environment can introduce potentially hazardous contamination. It can also contribute to loss of quality. Sanitation practices are required by Good Manufacturing Practices, GMP, including general cleaning and washing and sanitizing of equipment, walls and floors. See Appendix 5, Sanitation Basics. Facilities must meet all applicable GMP requirements, but documentation is required only for hazards requiring preventive controls. This chapter covers sanitation preventive controls identified through hazard analysis. The Preventive Controls for Human Food Regulation requires implementation of sanitation preventive controls, as appropriate to the facility and the food, to significantly minimize or prevent hazards such as environmental pathogens, biological hazards due to employee handling, and food allergen hazards. The hazard analysis identifies hazards requiring a preventive control. This chapter begins with a review of sanitation-related food safety hazards and hazard analysis examples. Then preventive controls to assure cleanliness of food contact surfaces and prevention of allergen cross-contact and biological cross-contamination from objects and personnel in certain facilities are discussed. Finally, monitoring, corrections, and verification requirements for sanitation preventive controls are addressed. Let's review a couple important definitions. Allergen cross-contact, the unintentional incorporation of a food allergen into a food. 21 CFR 117.3. Cross-contamination, the unintentional transfer of a foodborne pathogen from a food, where it may occur naturally, or insanitary object to another food, where it may present a hazard. Environmental pathogens such as Salmonella and Listeria monocytogenes are major food safety hazards for many ready-to-eat products that are exposed to the processing environment prior to packaging. Sanitary facilities are essential to significantly minimize or prevent these hazards from contaminating RTE food. Cross-contamination must be controlled to prevent pathogens from getting into the food. As discussed in Chapter 4, Biological Food Safety Hazards, foodborne pathogens can enter a facility on raw materials. Clean equipment and employee practices that minimize the transfer of these pathogens from raw ingredients to ready-to-eat products may be essential to effectively control these hazards. Employee practices are also important to prevent allergen cross-contact between products that contain food allergens and those that do not. As discussed in Chapter 10, Food Allergen Preventive Controls, food allergens can also be transferred from equipment that is not cleaned to remove them before non-allergen containing products are handled. GMPs and other prerequisite programs work together to establish a sound foundation for your food safety system. The considerations on the slide above are usually managed as GMPs, employee hygiene, personnel practices, and the design of the facility must prevent cross-contamination and allergen cross-contact. It is important for employees to understand that their actions can contribute to product contamination. Employees' hands or gloves, and equipment and utensils must be washed and sanitized when necessary after being contaminated. For example, employees working in a raw product area should not work with a cooked finished product without washing and sanitizing their hands, gloves, equipment, or utensils to avoid cross-contamination. Similarly, employees handling food allergens should wash their hands before handling food that does not contain those allergens to prevent allergen cross-contact. Personal cleanliness is also important to prevent product contamination and is generally managed through GMPs. Workers must wear clean and appropriate attire, and must wash and sanitize their hands at appropriate intervals. When gloves are used, they are not a substitute for hand washing. Leakage, cross-contamination, and allergen cross-contact can occur. Plant design must prevent potential contamination of stored ingredients and raw materials, food, and food contact surfaces, including separation of operations where contamination is likely to occur. This means separating raw product and unpackaged ready-to-eat product to avoid contamination. Similarly, separating foods that contain food allergens from those that do not contain the same food allergens helps to avoid allergen cross-contact. Food contact surfaces must be cleaned and sanitized, as appropriate, when contaminated. Packaging materials must be stored and handled properly so they do not become a source of contamination. GMPs related to cleaning and sanitation are addressed in 21 CFR 117, specifically 117.35 D, E, and F. These can be managed as prerequisite programs unless the hazard analysis identifies hazards requiring a preventive control to address allergen cross-contact or cross-contamination. For more information on basic cleaning and sanitation, see Appendix 5, Sanitation Basics. The hazard analysis process determines the hazards requiring a preventive control. Identifying specific hazards and preventive control procedures is required, and the procedures must be performed as designed on a continued basis to prevent the hazard. The E.G. Food Company's hazard analysis for omelets identified the assemble, wrap step as a step where a sanitation preventive control was necessary to prevent introduction of environmental pathogens such as L. monocytogenes. At this step, the product has been cooked and then handled so cross-contamination could occur. No other step in the process would eliminate environmental pathogens that might be introduced through handling after the cook step. The potential for allergen cross-contact from the wheat in the biscuit to non-biscuit containing products was also identified as a hazard requiring a preventive control at this step. The potential for allergen cross-contact can be significantly minimized or prevented through sanitation. Thus, the slide above documents the sanitation preventive controls that are required to be addressed in the E.G. Food Company's Food Safety Plan. Other sanitation practices are handled through routine GMP procedures at the E.G. Food Company's plant. The rest of this chapter focuses on sanitation preventive controls requirements and not GMPs. Lack of effective sanitation preventive controls has contributed to major recalls. When hazard analysis identifies a hazard requiring a sanitation preventive control, the procedures, practices, and processes used to manage these hazards must be developed and documented. As appropriate to the food, facility, and how the preventive control fits in the food safety system, this may involve procedures to ensure the cleanliness of food contact surfaces, including food contact surfaces of utensils and equipment. It may also involve procedures to significantly minimize or prevent allergen cross-contact and microbial cross-contamination. Preventing hazard transfer from insanitary objects, such as dirty equipment and environmental sources, and from personnel to food packaging material, and to other food contact surfaces may be appropriate depending on the operation. Preventing transfer from raw or unprocessed product to processed product may also be appropriate in some situations, e.g., from uncooked to cooked product, from unwashed to washed product, etc. Personnel can play a big role in preventing transfer of contamination. Food safety training is required by the preventive controls for human food regulations. This can help your employees to understand the important role they play in the food safety program. The E.G. Food Company example includes color-coded smocks for employees working in the assemble, wrap area as an example of a practice that can minimize transfer of environmental pathogens into this sensitive area if employees understand why they are required to follow this procedure. Cleanliness of food contact surfaces is a primary focus for sanitation preventive controls. However, prevention of allergen cross-contact and microbial cross-contamination requires consideration of sanitation practices for both food contact and non-food contact surfaces because of environmental pathogens. For example, when manufacturing low-moisture foods such as chocolate and confectionery products, dry cleaning procedures facilitate control of environmental pathogens such as salmonella. However, control of allergens may be easier when wet cleaning procedures are used. A facility must carefully consider when to use wet cleaning versus dry cleaning. Food contact surfaces used for low-moisture food must be in clean, dry, and sanitary condition before use. When the surfaces are wet cleaned, they must, when necessary, be sanitized and thoroughly dried before subsequent use. Moisture retained in environmental cracks and crevices can support pathogen growth, so use of wet cleaning in dry environments should be avoided when possible and should not be a routine practice. See Appendix 5, Sanitation Basics for more information on wet versus dry cleaning. Use of hygienic zoning to minimize transfer of hazards and considerations to minimize hazard transfer through personal practices may also be important, depending upon the process and the product. This is discussed below. Sanitation is not the only control useful in preventing contamination of foods. The concept of hygienic zoning was developed for facilities where raw and ready-to-eat products are handled. However, similar concepts can be applied for allergen control and for dry versus wet cleaning areas. Every facility has different needs, depending on the product, the structure, traffic patterns, and other factors involved with processing and handling food. Identifying areas that are specific to control of hazards requiring a preventive control and sanitation needs can reduce cleanup time if designed and implemented well. The slide above discusses different types of hygiene areas. Non-manufacturing areas do not require the same level of sanitation as food processing areas. Transition areas into a GMP or processing space should be equipped with materials to minimize the potential for transferring potential pathogens into the facility. For example, smocks, footwear, if needed, hair covers, etc. are typically available in transition areas, as well as hand washing stations. Sanitation needs in basic GMP areas, such as receiving and storage areas and those that handle raw product, that are physically separated from sensitive areas, e.g., where an RTE food is exposed to the environment, typically are managed by GMP requirements and not preventive control requirements. More attention to sanitation and primary pathogen control is needed in areas that handle ready-to-eat products that are exposed to the environment. Even more diligent efforts are needed in areas that handle products for sensitive populations such as infants. Control of traffic patterns between these areas with different levels of hygiene can minimize the transfer of hazards. Techniques that may be useful include dedicated equipment in different areas, especially when it is difficult to clean, e.g., carts, forklifts. Use of color-coded uniforms for people who work on the raw side and those who work on the cooked/ready-to-eat (RTE) side. Linear flow through a facility, such that raw product does not enter the cooked/RTE product area. It is understood that the aforementioned may not be practical in all situations. However, there is a requirement that efforts are made to prevent allergen cross-contact and cross-contamination when hazards requiring a preventive control are identified through hazard analysis. Preventive controls can address this through zoning and other means, as dictated by the situation at the facility. See Appendix 6, Hygienic Zoning and Environmental Monitoring for more information on this topic. Each facility must determine the need for and scope of a sanitation preventive control program based on the potential for product contamination. The assessment should take into account the physical structure itself, personnel, packaging and ingredient traffic flows, and any crossover areas. It should also consider potential contaminants from raw materials, airflow, support areas, and activities taking place in the facility, which may include potential allergen and microbiological concerns. The sanitation preventive controls must address targeted environmental pathogens if relevant to the product being produced. A facility may choose to use zoning for allergens if this is determined to be a concern through hazard analysis. The map in the slide is from the hygienic zoning example in Appendix 3, Food Safety Plan example. The assemble wrap area is designated as a primary pathogen control area with controlled access because the cooked omelets are exposed to the environment prior to packaging. If the hazard analysis identifies a hazard requiring a sanitation preventive control, written procedures must be documented in the food safety plan. This may include procedures, practices, and processes needed to ensure the cleanliness of particular food contact surfaces, including utensils and equipment. They also may include procedures to prevent cross-contamination or allergen cross-contact from insanitary objects, as well as from personnel to food, food packaging material, and other food contact surfaces. Procedures to prevent cross-contamination from raw product to processed product are also included in the food safety plan, when appropriate as identified in the hazard analysis. The most effective cleaning and sanitizing procedures contain the following elements. The purpose of doing the procedure to ensure that the operator understands why a sanitation preventive control procedure is so important. The frequency or when the procedure needs to be conducted to be effective. Who is responsible for performing the procedure and other tasks listed. The procedural instructions to accomplish the task, including identification of tools, chemicals, and specific steps, sometimes including pictures, especially if disassembly of equipment is required. Monitoring to provide a record that the procedure was performed. Corrections, or what to do when inspection determines that the procedure was not adequate to produce a sanitary surface or area. Verification procedures. The name of the form used to record monitoring activities. An example of the sanitation procedure for the e.g. food company's assembly table appears above. This is only an example of how a sanitation preventive control could be documented. The format used can vary considerably, and may even use photographs instead of words. Sanitation preventive controls must be monitored and results recorded as appropriates. The term monitor is defined in the preventive controls for human food regulation as to conduct planned sequence of observations or measurements to assess whether controls are operating as intended. As discussed above, procedures related to the sanitation process, as well as hygienic zoning, if used as a preventive control, require monitoring records. An example of the type of record that could be used for cleaning and sanitizing is illustrated below. An e.g. food company example of a daily sanitation control record for its omelet line is illustrated above. It includes several monitoring activities on the same form. Visual observation of cleanliness is one type of monitoring activity, recorded as satisfactory or unsatisfactory on the initial observation. Recording the sanitizer concentration is another monitoring activity, which documents the specific concentration of the sanitizer used. Test strips are frequently used for this type of activity. Make sure that a test strip appropriate for the specific sanitizer is used. It is entirely likely that a facility may want to use several different forms to record the information in order to locate the form where the cleaning takes place. For example, there could be a monitoring record located in the equipment cleaning room to record the sanitizer concentration in a tank used to submerge cleaned equipment parts, e.g., gaskets, cutter blades, etc. Other sanitation forms may be located in the production area next to the equipment being cleaned. The facility must determine how frequently cleaning and sanitizing occurs, an important consideration to minimize the potential for environmental pathogens to become established and to prevent growth of pathogens on food residues remaining on surfaces. A chemical supplier can help provide guidelines for cleaning frequency in many situations. Note that not all sanitation procedures need to be included in a food safety plan. Sanitation procedures conducted for quality reasons fall under GMPs rather than sanitation preventive controls and, thus, are not required to be documented in the food safety plan. The date, time, when appropriate, and initials of the operator performing the monitoring task must be included on a monitoring record each time they perform the task. When deficiencies at a sanitation preventive control are encountered, corrections must be made in a timely manner. The nature of the corrections depends on the specific situation. Sometimes corrections are relatively easy. For example, if food residue is observed on clean equipment, the equipment should be recleaned. If the sanitizer concentration is determined to be incorrect, a new sanitizer solution should be prepared and the equipment should be resanitized. Note that resanitizing equipment can be avoided if the sanitizer concentration is checked before it is used. The personnel cleaning the equipment may need to be retrained. The facility must determine how frequently cleaning and sanitizing occurs, an important consideration to minimize the potential for environmental pathogens to become established and to prevent growth of pathogens on food residues remaining on surfaces. A chemical supplier can help provide guidelines for cleaning frequency in many situations. Note that not all sanitation procedures need to be included in a food safety plan. Sanitation procedures conducted for quality reasons fall under GMPs rather than sanitation preventive controls and, thus, are not required to be documented in the food safety plan. The date, time, when appropriate, and initials of the operator performing the monitoring task must be included on a monitoring record each time they perform the task. Let's look at a very important definition. Correction, an action to identify and correct a problem that occurred during the production of food, without other actions associated with a corrective action procedure, such as actions to reduce the likelihood that the problem will recur, evaluate all affected food for safety, and prevent affected food from entering commerce. 21 CFR 117.3 Definitions. Corrections versus corrective actions. Actions to correct conditions or practices related to cleanliness and prevention of cross-contamination and allergen cross-contact must be taken in a timely manner. When timely action is taken, corrections such as those described in the cleaning procedure are adequate and, when appropriate, must be documented. If action is not taken in a timely manner, e.g., unsanitary conditions exist for an extended period, full corrective action as described in 21 CFR 117.150 is required, e.g., product on hold, evaluate risk, etc. The example in the slide from the E.G. Food Company example illustrates how corrections can be described in a cleaning procedure. Other correction and corrective action procedure examples are in Appendix 3 for other sanitation preventive control procedures. This correction procedure informs operators the action that must be taken if procedures are not properly followed. Because these are correction procedures and not corrective action procedures, completion of a corrective action report is not required. Verification is conducted to confirm that the sanitation preventive controls are properly implemented and the system is operating as intended. Review of sanitation preventive control records is also a required verification activity. Verification activities must be documented. The specific verification activities depend on the facility and how the sanitation activities are set up. For example, some facilities prepare sanitizing solutions every day. Other facilities use an automated dosing system that includes a monitoring device. In the former, checking the sanitizer concentration right after you make it is a monitoring activity. However, if you periodically check the concentration of an automated system, this is a verification activity. In either case, this can be accomplished through test strip, titration, or other methods frequently provided by the chemical supplier. The important thing is that the chemical concentration is checked and documented. Some facilities may use quantitative microbiological swabs, e.g., swabbing a 3 by 3 inch or 10 by 10 centimeters area and plating, or indirect methods like ATP monitoring to provide quantitative verification of the effectiveness of sanitation procedures. Environmental monitoring for an environmental pathogen or an appropriate indicator organism is required when an environmental pathogen is a hazard requiring a preventive control. This may be the case in facilities where ready-to-eat product is exposed to the environment before packaging. An effective environmental monitoring program diligently tries to find the pathogen or indicator of concern so that corrections can be made before product is compromised. Environmental monitoring is a verification procedure for such a facility. Corrective actions procedures, instead of corrections, must document actions to be taken when the environmental pathogen or an indicator organism is detected. See Chapter 13, Verification and Validation Procedures, and Appendix 6, Hygienic Zoning and Environmental Monitoring supplemental information if it applies to your facility. Sanitation is an element of GMPs that is required in all facilities. For some products and processes, the hazard analysis will identify specific instances where sanitation preventive controls are essential to protect consumers from contaminated product. Hazards requiring sanitation preventive controls depend on the facility and may include environmental pathogens when RTE food is exposed to the environment, pathogens transferred through cross-contamination, and allergens transferred through allergen cross-contact. Sanitation preventive controls focus on the cleanliness of food contact surfaces and prevention of cross-contamination and allergen cross-contact. When identified in the hazard analysis process, these sanitation preventive control procedures must comply with preventive controls requirements and be documented in the food safety plan. Required information includes monitoring activities and frequency, corrections for most procedures, corrective actions for allergens and environmental pathogens, if relevant, and verification activities. Good job completing the lecture. I hope you learned a bunch. Make sure you check out all the chapter resources. Please complete all the exercises and activities.